limit 0 to infinity. If we take square of absolute value of fx dx, it is equal to 0 to infinity, and Fourier transformation means a square of absolute value of Fourier transformation of C, or we can use for S also. Okay.
Okay.
If we have for cos, then we can use here C, or if we have sine, then we can use here S
Yes.
and D.
Okay.
So now let us do first question, means first
Yes,
part of
ma'am.
second question. Okay. And we have given cos fx. Okay. Yes. We need to evaluate this, and if fx is equal to e to the power minus ax, then its Fourier transformation is equal to square root of 2 by pi and cos into a over a square plus s square. And for sine, it is square root of 2 by pi s upon a square plus s square. We have done this already. Okay. So now let us find by using Parseval's identity. 0 to infinity absolute value of fx square dx is equal to 0 to infinity and Fourier transformation. Okay, first of all, we are taking for cos. So let us take here C S and absolute value square and ds. So now let us put value of each. 0 to infinity limit and integration, and e to the power minus ax whole square dx, and on right side limit 0 to infinity, and let us put the value of this transformation, which is square root of 2 by pi a upon a square plus s square into ds. And we have square, let's see, power of power, right? We have here power and we have power of power this. So obviously we can multiply. So we will have here 0 to limit 0 to infinity e to the power minus 2ax dx. And as we have square of this entire, so obviously we will have 2 by pi outside of square root square. And a square over a square plus s square whole square and ds. Now Let us take let us differentiate it.
Okay, ma'am.
So we will get e to the power minus 2ax over minus 2a by using chain rule of integration 0 to infinity limit is equal to, like, let us take these constant terms outside of integration symbol, and we have 1 upon a square plus s square whole square ds. See here, it should be uh, ds, you know. One second.
Ma'am, where?
Mhm. Yeah, yeah, I checked it. Yes, yes, this is x. Okay. So let us simplify using limit. If we use infinity here, then we will get 0.
Yes,
Here,
ma'am. Yes, ma'am.
sorry, 0 minus. And if we put 0, then its value will be 1, and it will be,
1,
yes, 1 by
2a.
minus 2a. Okay, so it will be, and 2 by pi a square and 0 to infinity limit, and 1 upon a square plus s square whole square and ds. And we have here 1 upon 2a and 2 by pi a square 0 to infinity limit, and 1 upon a square plus s square whole square and ds. And now we can write this as 0 to infinity 1 upon a square plus s square whole square ds is equal to pi over 4 and a cube. And they have given to us a is greater than 0. It means positive. Got it?
Yes, ma'am.
We found here for s. Similarly, we can find for x also. Like 0 to limit 0 to infinity. And in a state of ds, we can use x. Similarly, we can write here similarly. Dx over a square plus x square. In a state of s, we are using here x square is equal to pi over 4 a cube, and where a is greater than 0. Got it?
Yes, ma'am. Yes, ma'am.
And now let us find for, this is for cos, and now let us find for sine.
Fine.
By using Parseval'S identity. We will take it as integration limit 0 to infinity square of absolute value of fx dx is equal to 0 to infinity and hmm, square of absolute value of Fourier transformation for sine and ds. Now let us put value 0 to infinity e to the power minus ax whole square dx is equal to 0 integration limit 0 to infinity. And now let us put value of transformation for sine. It is square root of 2 by pi into s over a square plus s square. And we are taking whole square, that is why we are taking here whole square and ds. It will be the same
Okay,
answer.
ma'am. Yes, ma'am.
Yes. So e to the power minus ax 2. And we have also and we can take directly always. Remember?
Yes, ma'am.
1 by 2a is equal to. Hmm. And here we can find this outside the square root. So we can take 2 over pi and inside we have integration 0 to infinity limit. And s square over a square plus s square whole square and ds.
Yes, ma'am.
So we can express this integration limit 0 to infinity s square over a square plus s square whole square ds is equal to pi over 4a. Okay, and where a is greater than 0.
Yes, ma'am.
Similarly, integration limit 0 to infinity x square over a square plus x square whole square. Sorry, here we have ds. Dx is equal to pi over 4a where a is greater than 0. Okay, so we found both. You got each and every step.
Yes, ma'am.
And let us do next one. Third question. Can you do
Okay,
this
ma'am.
or shall I tell you? Check it.
Just a minute. Ma'am, I'll try to do it.
Okay. And next,
The third one.
fourth. Third, you can try you as you are
Yes,
saying.
yes, yes.
Fourth.
Fourth one. Yeah, we can do fourth one, ma'am.
Okay. Just a second. X is equal to theta. Okay, let's do this. So fourth is find Fourier sine transform of 1 upon x. 1 upon x is given as fx. Okay. So in fourth
Yes,
question,
ma'am.
So because we need to find for sine and for fx. So by using formula, it will be pi over 2 over pi, square root of 2 over pi, and integration 0 to infinity fx sine sx dx. So why we are like changing its angle? Because when we have angle having these limits 0 to 0 to infinity and sine x over x dx, then its value will be pi by 2. As formula we can use it. Okay, that is why we
Yes,
are
ma'am.
changing here angle, okay, accordingly to make this form. So put Sx is equal to theta, or instead of theta we can use any other variable also, like t or anything else.
Okay, ma'am.
So we are taking Sx is equal to theta. Then from here we can take x is equal to theta by s. And now let us differentiate it. Dx is equal to d theta over s. Are you getting me?
Yes, ma'am.
Now let us change the limit. If x is equal to 0, then theta also will be 0. If x is equal to infinity, then theta also will be infinity. And now let us substitute these values. So we have Fourier transform of sine of x is equal to square root of 2 over pi and limit 0 to infinity. In a state of x, we are using theta over x. Okay, because we have 1 upon x here also. So we have here theta 1 upon theta over s and theta, sorry, sine theta and d theta over s. From here, instead of dx, now we can cancel them. You got
Yes, ma'am.
0 to infinity. So we have sine theta over theta d theta. So its value is pi by 2.
Yes, ma'am.
By using formula, we can take it directly. So square root of 2 over pi into pi by 2. So we can take this pi by 2 as the pi square over 2 square. So we will have final answer is equal to pi by 2 in square root. Okay.
Yes, ma'am.
So this is required transform. So in fifth question, they have given to like you need to show this first part. Fs means sine transform of x fx. Okay, is equal to minus d over ds of okay transform of cos. Okay, so let us find like we need to find left hand side and right hand side both, or we can do in
Yes,
two
ma'am.
ways, like can find separately both right hand side and left hand side, and then we can show they are equal. Okay, or we can do it together also, like uh, together left side we can have transform of sine, and on right side we can find a derivative of transform of cos. So let us do this fifth first part. You can try second part also, okay, of the same.
Okay, ma'am.
So f s of x fx is equal to square root of 2 upon pi integration limit 0 to infinity. And in a state of x, we are taking x fx. So we will take accordingly x fx because we take here whatever we have here.
Okay, ma'am.
That is why we can take here. And into sine sx dx. And now, uh, right for cos. Okay, for cos, they are using only fx because they have like on right side fcs. So they are using for only fx. So you know very well fs is just for fx, right?
Yes, ma'am.
So now let us put, and this is equal to square root of 2 over pi integration 0 to infinity and fx cos x cos sx and dx. And we need derivative of this. Okay,
Okay, ma'am.
because to show this we need derivative, so let us differentiate this. D over dx, and we are taking d over dx of fc of, sorry, this square root of 2 over pi limit 0 to infinity fx cos sx dx. So if we find derivative, they are okay, they need with respect to s. Okay, they need with respect to s. Yes. On right side of this proof, see, they need d over ds.
Yes, ma'am.
So we will have square root of 2 over pi and integration 0 limit 0 to infinity fx we have as such, because this is function of s, we can take, so this will be minus sine s x into x by using chain rule
Yes, ma'am.
and dx, which is equal to square root of 2 over pi and 0. We have negative sign here. Limit 0 to infinity fx. And we have here x also. I can write as in dx. And this is equal to, we can mention this first as first. So we can mention now as from first. D over ds of f c s is equal to minus f s of x fx, or we can write fs x of fx means Fourier transform, sine Fourier transform of x fx is equal to minus d over ds Fourier transform of cos of s. See, Fourier transform of cos we can say. You got?
Yes, ma'am.
Similarly, you can do second part also. Okay? You
Yes,
got
ma'am.
each and every step?
Sorry?
I'm asking you got each and every step?
Yes, 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 yes.
So you can do second part yourself?
Yes, ma'am. Yes, ma'am.
Okay. And next. And rest of questions you can try because they are same as previous one. Only like function part is changed only. Like sometimes they are giving us instead of e to the power minus ax, they are giving us x into e to the power minus ax like this. So you can try yourself. Is that okay with you? If you
Yes, ma'am.
face any problem, then you can ask me. And
Okay, ma'am. Okay.
for tomorrow, I'll keep your class earlier. Okay, so that we can do extra also. Okay,
Okay, ma'am.
so just try these all questions and so that you can tell me your problems whenever you find. Otherwise, we'll use next topic tomorrow. Okay,
Okay, ma'am.
all right.
Thank you, ma'am.
Okay, well,
Just let me take screenshot.
sure, you can. From the beginning, I'm showing you. Just
Yeah, done, ma'am. Thank you.
okay, well.
Okay.